Welcome to another lesson with Ming. Today we will extend our discussion on logarithm. Here are the learning targets. Alright, let's review our definition of logarithm. For this particular thing, a raised to the power of y is equal to x can be written as logarithm x base a equal to y. Basically, logarithm is a way to ask how much a, the base, has to be raised to get x. In this case, it's the y. So the answer for logarithm is always the exponent of the base. Alright, and basically the properties number 1 and properties number 2 are the summaries of the previous lessons, and we have to remember here that a here there's a limitation. A here must be a number greater than 0. For higher level students, later on you may want to consider a to be a negative number. Alright, so properties 1 basically say if the base and the factor are the same, then the answer is 1 because the base has to be raised only once to get a. And here the base has to be raised 0 times to get 1 because a to the power of 0 is 1. Now beyond this, there are a few more properties of logarithm, and here are the rest. The first one says that number 3 says is that if your factor is raised to the power of y, then the factor basically comes down to the front, right? So here the exponent, when you have a log, it kind of slide down to the front of the log. And if the index here is -1, well, basically number 4 is a special case of number 3 where the index now or the exponent is -1. So when it slides down, it becomes negative of the logarithm. And number 5 is actually the same as number 4 because 1 over x is also written as x to the power of -1. So number 5 and 4 are exactly the same. And if we have the addition of 2 logarithm, because we are adding indices, right? So the answer to that will be the logarithm of a product with the same base. Base A, base A, base A, and you can see that. And if you have the difference of 2 logarithm with the same base, then the answer is the logarithm of here is x over y, base A. Opposite of index or exponents. In index or exponents, we have this a to the power of m times a to the power of n is equal to a to the power of m plus n. So you can see that here is the product and here's the addition, and the opposite to that is what we have in logarithm. And for number 7, we have another rule that say a to the power of m divided by a to the power of n is equal to a m minus n. That is, you take the difference of the indices. So the number 7 is the opposite of this. Number 6 is the opposite of that. Welcome back. Let us attempt these questions. Alright, logarithm 7 base 7. That basically asking how much the base has to be raised to get 7. The answer is 1. And it's actually very easy to recognize, right? And the second one is logarithm e base e. How much the base e has to be raised to get e? Well, answer in this case is 1. In fact, you realize that when the factor and the base are always the same, that is, the factor and the base is the same, then the answer is always going to be 1. And the next one, logarithm 1 base 10. How much 10 has to be raised to get 1? Well, in the case it's 0. How about the next one, ln 1? That means basically logarithm of 1 base e. So basically it's how much e has to be raised to get 1. the answer again is 0. And here comes from a raised to the power of 0 is always equal to 1 as long as a here is not equal to 0. In terms of logarithm, a has to be larger than 0. So here is again the first one. Base and the factor are exactly the same, so the answer is 1. The factor is 1, base is 8, so answer here is 0. 8 has to be raised 0 times to get 1. Now this case is 10. Base is 10 and the factor is 100. How much 10 has to be raised to get 100? The answer is 2. Now next one is a bit tricky. It says how much 4 has to be raised to get 2? If you're having trouble doing this, you can write this as x, for example, and then use that definition, that is 4 raised to the power of x is equal to 2. And then 4 is 2 to the power of 2, x equal to 2. So 2 to the power of 2x is equal to 2. Therefore, 2 here in the right hand side, this is basically raised to the power of 1. Therefore, we have 2x equal to 1, x equal to half. So the answer for this is actually half. Well, this is actually makes sense because, well, we can think about, well, the square root of 4 is actually 2. The square root of 4 is actually 2. So here's the answer. I hope you got all of them correct.